Hello, everyone. Welcome to our 8th webinar of this series. My name is Rodrigo Romarowski. I'm a member of the student committee of the ESB, of the European Society of Biomechanics. So today we have a new webinar in our series. The structure, it's called Python, Everything You Need to Know for a Daily Scientific Programming Work. The structure is going to be the same as in all the webinars. So we will have a presenter, which I'm going to introduce right now, that is going to speak for about 45 minutes. Today, we do also have a live demonstration. And then we will have 15 minutes for a Q&A session. So what I will ask you is to write on the chat of the GoTo platform all the questions you have. We're going to collect them, and then we are going to moderate and exchange some stuff together at the end. Before introducing our speaker today, please don't forget to subscribe to our YouTube channel. It's youtube.com/ESBiomech. So there you can also see all the past webinars, and we are going to upload today's webinar once we are done. So click the notification bell and everything so that you are tuned and you don't miss any of our new webinars and all our news. So back to today. Today's webinar is going to be conducted by Professor Dieter Park. He's an important part of the ESB for many years. Dieter is a full professor at TU Vienna and Karl Landsteiner University of Health Sciences in the field of biomechanics. He is giving an introductory lecture to mechanical engineering students at TU Vienna using Python. Personally, I'm very interested in this webinar because in my life I've been using Python for a long time, and it's a very flexible tool, as we are going to see today. So once again, we have 45 minutes of presentation followed by 15 minutes of question and answers. And that's it. So I hope you enjoyed the webinar. I'm going to give the floor or the screen, in this case, to Dieter. And thanks a lot for joining.
Thank you, Rodrigo, for this very kind introduction, and also thanks to Eshan helping us with the organization. And I'm now sharing my screen. So let me start first with a few words about this webinar. So I was already introduced. I'm at the TU Wien at the Carling Grams. I've also founded a company actually which is distributing the software Mattool. So if you're interested in, also visit our group here because I have a joint group at 2 different universities. And actually, I did for many, many years actually programming by myself. Was then also here getting a lecture for the first semester in Vienna in programming. And the first thing I was asking when I'm preparing this seminar, for whom I'm actually doing this seminar. So what are your skills? What is your motivation? And I'm quite sure it's very diverse. That means maybe there are some beginners here who have no programming experience. There are maybe some explorers here who would like to know programming, know already programming, but like to know a scripting language like Python. And maybe there are also switcher here. That means they know very well a programming language, but during your scientific life, you detected Python becomes very, very important for many applications. So I tried to address all of these things. And of course, 45 minutes is not like a full lecture at the university, but I'd like to give you at least some ideas. So please be don't disappointed if your expectations are not met 100%. It's not that easy. So let's come into Python. And actually, if you're talking about Python, you have to talk about Monty Pythons. Why? Because the naming Python goes back actually to these guys here. Maybe some of you know this, very funny flying circuits, Monty Python, crazy British comedians. And that was actually also the reason why the programmers of Python decided to simply take the name Python. So it's not going back to a snake, even if it's then the symbol. You can see here is some kind related to a snake, but there are really cool things you can do with Python. So you can do like web developments. scientific and numeric computing. So that's what we are talking about today. Machine learning, web applications, and you can also use Python, for example, for robotics or programming like Raspberry Pi or something like that. So quite cool things. And as you see here, in Python, there is no semicolon. In Python, there is no brackets. So that means in Python, you have no problems. Well, if it would be that easy, it would be nice, but it's actually not. So, but maybe also a few of you also come from the Matlab world. So very, very well-known commercial software product. And the good news that with a collection of Python libraries, you can simply replace Matlab. Simply, yeah, of course, if you have lots of programming done in Matlab, it's not that easy. But Python itself, it's a core programming language. And on top of Python, there's a huge number of libraries like Numpy and Scipy, I will talk about today. Also Matplotlib for plotting and the data structure Pandas. So if you combine these four guys with Python, you get something which is quite equivalent to MATLAB. The good news, everything is free. There is a huge society, a community behind it. So you don't have to care if you switch the university, if your new university also has MATLAB or not. So you simply have it. The first question when you start with Python is Python 2 or Python 3? Actually, that's not a question. Python 3 is not maintained, Python 2 is not maintained anymore, so I strongly recommend if you start with Python 3. Then what kind of Python package should I use actually? There are thousands of them available. So my recommendation was Anaconda Python. So and also you got an email where you could download it. So quite simply, if you go here to anaconda.com, you see here there is a download available for Windows, Mac, and Linux. Actually, behind Anaconda, there's a company that has pros and cons. The good thing is they have an individual edition, which you can use for free, and you have it for all platforms. So that's also the reason why we use this for also for our programming courses. And there comes an integrated development environment. That means if you install it, and here I have the installation of Anaconda. You see it comes here with these tools. You have Spider. I will come to Spider in a minute. So this is the integrated development environment. But there also comes with other things. That means you see here Anaconda Navigator. What does this mean? Anaconda is not only pure Python. So coming back to our installation, it has at least, of course, these libraries included and around 100 other libraries which might be interesting for you. So it comes like, you know, maybe ImageJ and Fiji. What is the difference? Fiji is just ImageJ with a bunch of interesting libraries you need for image processing. So it's the same thing with Anaconda. So Anaconda is a Python version with packages, but you can easily add up packages if you need them. So, and Python is simply the programming language. So what you need is an integrated development environment. And that means you need actually here Spider. You can also use UPython Notebook. I will not go into these things. This is a bit related like Matcard. So a tool where you can do more or less both things, coding and also like making a report. I will not go into this today. I simply will use Spider. And if you use Spider and you open this Spider the first time, it comes like this. So maybe you're a bit overwhelmed with these things. And I will explain this in a minute. So a few more words, where to get help. Actually, I would recommend getting started tours, looking at official Python docs. If you like, you can also look into our lecture here. It's in German, but Google will help you translating it. There we designed the lecture, the course for mechanic engineers. So that means it should be a good way to see what is the important thing for a mechanical engineer. Of course, also mechanical engineering and biomechanics is not that different. Yeah, and that brings me to the webinar content. So we will go over these things, but I will not read now this this list, that would be boring. I simply like to step into Spider. So as I said, when you open Spider, you first get here this window. There is a temp.py file. So you see already the Python files are stored with the ending py. And what you can do is you can simply, as our first command, so for those who already have Spider installed, open, you can simply also type here with me. You can simply say, I'd like to print. And you see here already a nice function where you get the information about what can you do. You can, for example, here give a value. So I simply say print hello. And now I could store the file if I'd like to, which I strongly recommend. But now simply let it run, and the simplest way to run it is click this button or simply F5. So you run it and you see, oops, there was something going on here. It says run file, and you see here, not very spectacular, but still there is already some output here on this so-called interactive Python shell. So what else? I have here some windows, and let's go first to this one here, the so-called variable explorer. So let's define a variable. For example, the variable a is equal to 5, and let this print and assign the variable. And if we let it run, what we see here in this variable explorer, usually we should see the variable. Interestingly, I cannot see it here. Maybe I changed something before. Yeah, but yeah, we'll see. And you can, of course, also print this variable. And you can also do something with this variable that you are, yeah, I have to see here why it's, so usually, interestingly, it should show here the variable a with some numbers. And yeah, anything is here. I will have to restart it, but I'm not restarting Spider right now. So these are very first steps. So here I have a file. Here I have an output of the file when I let it run. And here I'm getting some other information. I will not talk about the details here. And like to directly step into our coding example we will do today. And I already prepared here a file, so you could, for example, save this file. I save this here as myscriptwebinar.py. You can save this on a folder, whatever you like to. And what you see here, what I already did, I changed here what's inside this triple semicolons. So sorry, the triple thing here. And what is this? You see here, it's already heading. It's usually predefined here if you open Spider, but I strongly recommend simply give here a date. Maybe you are defining the author, and then you can start coding. And the first thing I'd like to do here, I do some printing. I'm printing out the blank line. I'm printing here many equal signs to have a nice like border. And again, and I'm printing also here, maybe you see here the backslashes. So to see what it's going, I'm quickly remove this here. So if I'm doing this and I let it run, you see it's doing nothing else than saying, tell me here, ESB Webinar. So I like this because it's a nice structure. And then what I'd like to do here, I simply like to print here our first thing, variables and operators. What would be if I simply comment this out? So we see already comments are, for example, either make with this shark symbol or with this triple things here. And if you let this run, you say there is no space in between, and there are so-called magic characters like this /n is simply producing a line feed. So there is usually one line feed always after a print, but if you'd like to have more line feeds, you can either like this, or you can make this. So, okay, and now we already said here variables and operators, and we'd like to see, okay, what are the possibilities? So what kind of variables and operators can we do? So I can, as I already did before, I can say there is a variable which I call a, and you can make it blank here or not. I'd like to make it blank because it looks a bit nicer. And I assign here to a an integer value. You can also assign, for example, to b, let's say a float value with a point, not with a comma. So in Germany we have the commas, but it's a point. But you can also assign a string. That means you can simply say, oh, here, for example, okay. What else can you do? You can now have a new variable where you simply, for example, say a plus b. So you add up a plus b, and finally you can, for example, do a power. A is, or let's say e, is simply the power, and this is a special thing. It's a double star 2. So now let's simply print these things. So for example, I say print a plus b, and what I'm getting here, variables, a plus b is 7.14. That's correct. So print d. So let's print d, and we see here d is, of course, the same thing. So what I can do in the printing command, I can also evaluate. Maybe that's not a good idea because then it's not stored the value as a variable, but maybe it's a good thing. And then I have a third thing here. What you can do, you can write a print command, and you can start here with an f. So what does this f mean? This f means there comes now a formatted string, and there is, let's say, there are variables in it. So that means Python interprets a plus b simply as characters is equal, and these are the magic brackets here. What's inside this magic brackets is interpreted as variables. And in case you have here a plus b, it's evaluated and then outputted. And also here you see c is the variable which is evaluated. And if I let this run, you say here you see here a plus b is this, and you see c was the string is okay. If you would simply write c here, what would happen? C would be simply interpreted as a character in this string. But this is quite a nice thing to quickly combine variables with simply here other kind of strings. So this is this formatted output. So this is actually very easy, and I will not go now over all operators like minus, like division, and so on. Can simply read this up. So that's very common, like you're used also from other programming languages. But there is a but. What happens if I say a is equal a times c? That means I'm multiplying an integer with a string, actually, and I'm reassigning now a to that what comes out. And printing this now here, as a print a. So what is the result? And you see, what is the result? It's okay times okay times okay times okay. That means this operator in combination with a string means make a new variable where you compose this string 4 times. And the but is here, the new variable a is now reassigned. And if you compare this to C or C++ Fortran, where you say, okay, you have to declare a variable at the beginning with integer or with a string or something like that. It's not the case in Python, which makes it on the one hand side very easy, but on the other hand side very dangerous, because for example, if you would have here an operation f, there you say I have here like 10 divided by a, and let's say this is not done here, and we say here print f. What's coming out? Well, cool, evaluated correctly, and then anywhere in between the code you're doing this, and you let the program run, and suck, you have an error. Why? Because now you try to divide 10 by okay, which is not possible, right? So that means this redeclaration of variables could be easy, fast, but it could be also very dangerous. So that means, again, to do this, it's not working, be careful with this. Actually, that was already the thing. I'd like to talk about operators and variables, and I'd like to move forward to data structures. So what are typical data structures in Python? Actually, typical data structures are, beside regular variables, what I already show, for example, lists. So I define a variable which I call my list, so an arbitrary name, and list usually starts with these kinds of brackets. So if I say, okay, I have a list here with 7, for example, 4 and 6, this is a nice list, and I can print this list. You see formatted output, list is equal, print the list, my list, and if we do so, you see here list is equal this. So this is already some data structure, and there's also a second cool data structure actually, which what I would like to show you. These are dictionaries. So my a dictionary. What is a dictionary? The definition starts with these kinds of brackets, and I can say, for example, I have, let's say, a coordinate x, which is in this case, for example, a character or a string. I apply here a value of 7, and maybe I have y, which is another coordinate, which has a value of 4, and I have here, for example, z, which gets a value of 6. So you see, in principle, I have 6, 4, and 7, 4, and 6. Here is a list, very compact, but maybe if I say, okay, I'd like to relate 7 with some coordinate, I can do the following thing. And if I'm printing now the dictionary, I see here this link, let's say this list with references. And usually this first quantity here is called the key, and the second is called the value. And if you, for example, like to now access something from the list here, what can you do? You can simply, for example, say print list element 1. So list element 1 for you is this element here, and you have to say my list brackets 0. Why? If you let this run, you see list element 1, the indexing of a list in Python starts at 0. So this is the same like the indexing in C++, for example, but in Fortran, for example, the indexing starts really at 1. So that means 1 means 0. And of course, if you know that 0 is x, 1 is y, and z is 2, everything is fine, but maybe you have, for example, nodes of a finite element mesh you read in, then it's getting a bit tricky. And if you see now how we can access a dictionary, you see the dictionary element x is my dict, and the nice thing here is you simply say you give here the key. So that means you don't give an index, you give the key. So you say I'd like to get from this data structure the element with the key x, and that's the way how you can access here this quantity. So usually these are two very important data structure actually be using all the time. Yeah, so data structures, there are of course other things, more details. So as I said, please look this up. And I'd like to go on with logical structures. So if else cases. So it's always necessary to have some logical structures like loops, if and else, as I said. And now let's first try out the loop. So I'd like to have a loop which is running through 5 times. So I define a variable n equal with 5. And I'd like to have a loop which is now running 5 times. And simply the loop starts with the keyword for. I is now a running variable which will be set. So I say for I in, and in what? In the range. This is a function, this range function. Maybe I have to do it a bit slower. So you see the range function needs you can simply give a stop value, or you could even give a start and a stop value. So I'm only giving a stop value, and my stop value is n. Usually what I'm doing, you see I'm coming to the next line, and there comes now a first important feature. You see that Python is jumping in. In C++, you would need to write something like for anything, blah, blah, blah. And then you have to write the brackets like this. This is not necessary in Python. So how does Python know that what is the body of this for loop? Actually, you have to have these indentations, and it's done automatically. So if I write print I here, and let's see what this is doing, you see it's running from 0, 1, 2, 3, 4, 5. That means it's running 5 times through. If you would do like this, yeah, it's not easy. So let's do this. You see, first of all, here an error. You would need here something. So it cannot be that there is a for loop without anything. So there's a statement pass so that this disappears. But now if you let this run, so what you see here, the output is 4. Why? Because I was set here in the last run with 4, and you print it out, and it's not, and this body is outside of the loop. So to get the correct behavior, again, we have to do this, and everything is fine. So, but what we'd like to do is, of course, making it a bit more interesting. And I simply say here, okay, let's combine this print statement here with an if case. So I say if I is equal to, I would say here this print command. And in this print command, I say, okay, I'd like to have a formatted output. And in this formatted output, I first write here I, the number I have, and I simply say here it's inside if. Why? We'll see in a minute. So let's do this. And you see we let it run. Logical structures, 2 inside if. It means if E is equal to, it jumps into this here, and we can do here something. And I already prepared here other cases. So the first case you can check, for example, again, if I is equal to, do this. Elif I is bigger than 2, do this. And you see here, I simply print here, if I is inside elif, I can let this run. And you see here, okay, 2 is inside the if, 3 and 4 is inside the elif. That means if this here is fulfilled, this here, this is never checked. So it simply jumps out of this if cases. And if you would now stop here, this is very dangerous, because you see, you never know if you maybe missed something here, and you see it immediately what we missed something, namely, we never have a check what happens if I is, for example, 0 or 1. That means it's always good to have an else case, which means if this is not fulfilled, check this. If this is not fulfilled, check this. And if we let this run, what you see here, 0 inside else, 1 inside else, 2 inside if, and so on. That means we see very nicely that now we are we really jumped through all the cases. So that's quite basics, of course, but it's important that you start at these basic points. So what's the next thing I like to show you? The next thing, which is of course important, is reading and writing. So let's first check the reading. And a very nice thing is what you can do. If you read something, you can simply say my file here, and there is a file. And now the question is, what should I give here? You simply give the file name. So it's I have a file in my actually folder, in this folder here, which is called my-test.txt. So that's my-test.txt. I'm opening the folder. So this is the webinar, and there is my test.txt file. You can open it, and it says in here, hello world. So you can do this with an editor or something else. This is simply a text file. And if I now have this file, first what I can do, I can say, okay, I'm now starting an output which says write text to a file. And what is done now? Nothing actually. We have now, if we have this file, we have to open the file, and then we have to write something. And there is a quite cool way of doing this. You can say with an open file, and this open file is my file. This is the variable, and I'd like to write on this file. And I do this as file object. So what is this file object? It's something like the standard out, you know, maybe from, or the C out in C. And this file object is now something where I can say file object dot write. And now to see that I'm really doing something, this is the live demo. I say now write on this file you showed before. This is the live demo, and if something would happen here, it would raise an error. But now I can simply write information on it. And you see no errors. It says here write to the file. Let's go here and see what's in the file now. And you see a change here. This is the live demo. If the file would not be already existing, it would simply create a new file. So quite easy if you'd like to store information. And of course, you can also read from a file. And you will then have actually the this Python file available, of course. I commented this out. This is foreign homework. That means you can really try to now read a file. And the file is a my-data CSV file. So this my-data CSV file is, you see here, Microsoft Excel CSV. You can either open this with an editor. You see it's a XY file, very simple. And of course, you can open this with Excel, but for the time reasons, I will not do this. And you can simply create here a time and a data list, which is inside this file, and store it to two lists. As I said, I will not go over this. It would be quite some time consuming. I would like to show you a much more easier way. Namely, I'd like to use Pandas. Pandas is this data structure you can use, which is an add-on, and you can easily read this file with Pandas. And if you'd like to use Pandas, the first thing you have to do, you have to import Pandas, because Pandas is not inside the inside the standard Python. So I say import pandas, and now I can say read into a data frame, simply abbreviated with df, and I'm using the pandas dot read function. So I'm not using the read or write function, which is related to this file object. You see it also, there is a read function also here. And I'm using the pandas read function, which is another read function. And pandas has a nice read function to read CSV file. You see, it's already recognizing it, that there is this function. So quite cool. I make the brackets. It tells me what I have to give here. And what I give here, simply my data CSV. This is the file path or buffer. And I simply say here, if I'm looking into the file, there was, is there a header or not? Let's open this file again so that you see it. So you see there is a header actually, but I'm using this header already here to create my data frame. So there is no additional data which should not be read in. So I say there is a header equal 0, and or my header of the data frame, let's say it in that way, is at the line 0, and the separator is a semicolon. So of course, what I write here very quickly is have to be read up carefully. You see, I'm missing here equal sign. So I always put this out, read it, and now let's print it, the data frame. So I'm printing this object, and now you see Pandas already reads this in one shot, and I have an index here, like in Excel. I have a time and a data entry, and I can access this time by simply say, okay, take from the data frame the time, which would be this column, and list means make a list out of it. So that means, what I could now say, see here, I now converted the first column to a list. On the second column, also to a list. So this is quite a powerful way of quickly reading in data. Yeah, but now, after so many words, coming a little bit to the scientific working. So actually, lists are cool stuff. And let's show the following problem. If I have a list and I print the list, and this list is simply the data list, which actually I see here. I read in this data list here. So I simply uncomment this so that I'm getting no error. So this is the list, which is actually the same list from Pandas. And what's happening if I simply say I'm multiplying this list by 2, and actually what you maybe like to have, that this is multiplied by 2, this. But if I'm doing this, you see the list is simply done twice. So this is not what I'm intending. So how can I now use this list for data arrays? Actually, the answer is quite simply, there is another library, and the library is called Numpy. And this Numpy library is a library. You will see in a minute what it does. First, I imported Numpy. And if you're a bit lazy and not always like to write, if you create a Numpy data, numpy.array, simply only NP, you can import Numpy as NP, which is an arbitrary name. And then you create in Numpy an array object from the data list. That means you take this list and convert the Python list into a Numpy array, also one P array. And if I'm printing this stuff here, let's show this. You see, you get the Numpy array. And now the cool thing, what you can do is I can multiply this by 2. And what I'm getting here is exactly the result what you're expecting, namely every entry of the array is multiplied by 2. And there are, of course, many other things you can do here. So let's try out the following thing. I simply say I'd like to print. I have this numpy, the numpy function np, and I'd like to get the minimum of the np data array. Right? And because I'm also like to have the maximum of this np data array, so let's see how this looks like. So you see, okay, I have here these new numbers. Is this correct? Yes, this is the smallest value is this one here, and the biggest value is this one. So there are many functions actually in NumPy to do this. And what you can also do, of course, you can access things. You can simply say np data, and you can access actually the data in this exactly the same way like a list. So you see here, list entry 2 is 0, 1, 2 is this number. So that means it's quite an interesting thing, and you can do a lots of things with NumPy, and it's more or less that what you know from Matlab, right? So it's a very powerful thing. But in NumPy there are also other cool stuff actually. Namely, first of all, you can of course also define a NumPy array, and let's define once an array by hand. I'm defining this NumPy array, starting with this, and I'd like to have a 2-dimensional NumPy array. And this 2-dimensional NumPy array simply consists of 1 and 2, and in the second, so it's a matrix actually, comma, I have 3 and 4. So, okay. So first, print the array and see what how it looks like. Yep. So there is an error here. So where did I miss something? It's a 1 and a 2, and I'm missing here for the 2-dimensional array bracket actually. So, yep. And you see here a 2-dimensional array consisting of 1, 2, 3, 4. And now you can do all linear algebraic operations, you know. For example, a.t means you make the transfers of the transpose of this array. You could, of course, also doing things like you can inverting. So for inverting the array, you simply take from NumPy. There is inside NumPy something, you see it already, the module linalg. And in the linalg, there is a function inverse. And in this inverse function, I can give the a, and I can simply compute the inverse. And of course, you could store this again to an array. You can manipulate the array. You can do linear equations, vector matrix multiplication, dot product, cross product, everything you can imagine. Yeah, so that was actually the basis, arrays, and now coming to a bit to plotting. So plotting means first what you have to do, you have to import actually the module for plotting, and the module for plotting is Matplotlib. And I'm importing this as PLT because I don't like to always write this stuff here. That would be a bit too much for me. And I now like to plot the data, for example. And therefore, I simply say PLT plot. I'm using the plot function and simply plotting, for example, from this data frame we had before. I think it was here. Plot the time and the data. So simply I say take from the data frame the time, take from the data frame the data. Yeah, and now I have also to say how I would like to plot it, and I make an O here, and O means plot this data simply with points. If I so work. If I'm doing this, you see here actually nothing, but if you go to this plot window here, and to see that it's really doing something and plotting time over time, which is of course a line, and time over data. And you see here, you have the plot here. Actually here it's doing all the plots, which you can simply erase with this one here and can replot it. And of course, if you're at the plot, you can store this plot. So you can save this plot here. Yeah, so this is a very quick thing you can do. And now let's do a bit more sophisticated plotting. And for example, I would like to interpolate here this data. And for interpolation, you will find an interpolation function in Scipy. So recognizing here Python, Numpy, Matplotlib, Pandas, and now finally Scipy. And in Scipy, what you simply do here, I'm first defining x and y. You see, simply because I'd like not to write always df for time and df for data, and to be sure that you see it's the thing what I'm doing is correct. Let's print this, and you see I'm simply have here. Oops. I'm simply have here an array of data type float with my y values in it. So, and now what I'd like to do here is interpolate, and this interpolate is a function. The function f is a variable, and the inter pl1t is this. And you see, I have to give an x and y. The cool thing is I defined this already as x and y. It's already done. And if I'm now clicking run, you see nothing happens, because what's done here, this is constructing an object which can be used then for plotting. And this 1D interpolation is simply means you do lines in between the points. A more nicer thing is F2. It's, for example, a cubic interpolation. I'm using the same function, but the kind is cubic. So we'll see in a minute what's the result is. And now we're doing the plotting. Actually, there is for the plotting, I need here, I have a function. I have to give the x values for this function, and the x values I simply define as x u, and I'm generating this simply by Numpy. There's a function which is called lin space, and this lin space function takes as arguments usually a few arguments, which is 1 till 11, for example, and I'd like to have in total, for example, 41 values, and endpoint means I also like to add the 11th point, otherwise I would have 1 point less. You can simply say this is true. So to simply check what this means, I'm simply printing this x new, and the output is, you see, I'm getting now, let's say, the x values here from 1 till 11, but I have more values in between. Namely, in total, I have 41 values. So it's the same thing like you're working with MATLAB. You have to always generate the x, the discretization, and then you feed this into a function. We don't need to import Matplotlib because we already imported here, but I'll let this here in case you are you'd like to use only this function alone. And now I'm generating first the figure. I'm not directly doing this plotting. I'm first generating a figure. You will see y. Then I'm plotting in this figure x and y. That means I'm plotting the dots. So let's delete this. I'm plotting first the dots with dots, and then I'm plotting x new. That means with this array, the function of this x new with, you see here, this line type, and I'm plotting x new again over f2 x new with another line type. And if I'm let this plot, you see now the points, the first plots, then the orange thing, the colors are here chosen simply by default. You can use this also if you like to, you can change this. And the green thing is the cubic interpolation. So it's that easy, that simple to do this. And if you'd like to add a legend, for example, it's this command. I will not go into details. It's self-explaining. You let it plot that you see here simply the legend to this date. So this was nearly the thing I'd like to show you. So one small thing more, image processing, if you're interested in. There is a package which is called scikit-image. And what I can do, for example, I simply can load an image from the database of scikit-image. So it's from the database, which was imported here. And there is an image which is called coins. So you see it's already loaded here. And what I'd like to do with this, I'd like to apply a Sobel filter to detect the edges. So I'm creating a new image, which is called edges. And I simply call from the filters option the Sobel filter. And in the Sobel filter, I simply feed in the image from before. And finally, what I'm doing here, because if I let this run, yeah, Sobel is actually like this. No, it's filters Sobel, yeah. As you see, nothing is done here, but if I switch on the plotting, a figure, I give the figure a typo. I'm showing actually the image, the coins in grayscale. I'm again creating a figure and I'm plotting the edging, and I call this figure coin Sobel. And if I let this run, delete this and let it run. So you see here, this is the original image plotted with Matplotlib, and this is the Sobel image. So simply the edges extraction. Yeah, so that was a very quick crash course actually in Python. And so roughly speaking, that was everything I'd like to show you. And of course, you have to go into it, look at this in detail. But I hope I could give you some ideas. And the next step is, of course, code. Try it out. And Python and IPython, you already showed. This is this shell next to it, Numpy, Scipy, Matplotlib. I didn't show you UPython, which is another way of integrated development environment. But I show you Pandas, I show you scikit-image. You can use scikit-learn for machine learning, or Seaborn, or statistics module. So everything is there. And this is actually the picture you need to do scientific. And with this, I'd like to thank you, and I hope you have fun with Python. Thanks.
Thank you very much. Thanks, Dieter. Thanks a lot. So the floor is open for questions. You can write them either in the question part or in the chat part, and I will read them aloud. So we have a few minutes. I have two questions. So the first, I already use Python, but for those that are planning to, after the webinar, to move to Python, can you give a hint about the speed of the operations compared to, for example, MATLAB, which is a high-level language, and compared to C++, or you also mentioned Fortran, which is a very low-level language. So what can we expect, like in terms of timing, in a for cycle or in a search or whatever?
Yeah, I don't know the actual numbers actually, but 10 years ago, you say Python is cool to program fast, but it's slow. The point is, it's not the case anymore. So when we started the Matplotlib development based on Python, we had some Fortran modules beside it, which speed up the stuff. I would not do this anymore. The reason is pure Python is already extremely fast. extremely easy to develop. You have lots of problems if you link Fortran or C. Yeah, I think one way to even get some speed is using Python, right? Which is some kind of C-based Python. But for us, I would say comparing efficiency, the easy thing, if you then in 1 or 2 or 3 years, when you have to port the code to a new Python version, I would say stick to pure Python. It's get always faster. It's already quite fast. And I would only change the programming language if there's really need, because if you have to do computations for 1 minute or 2 minutes, who cares, right? If the computation take 1 hour or 1 day, you have to think about speeding. But usually there are lots of interesting concepts in Python which are already extremely fast. For example, if you use Numpy arrays instead of lists, you will see a huge speed up because behind Python is C. And so performance is not an issue, I would say.
Great.
In 90–95% of the cases, it's not an issue. Use pure Python, my suggestion.
Okay, so we have a few more questions. So you showed us that this is an interpreted language, not a compiled language. So yeah. Somebody asked, is it possible to compile and build an executable file from a Python script?
Sure. So it's possible to compile Python. Of course, then you are not platform independent anymore. It's generating a PYC file in Linux, for example. It's generating a PYD file in Windows. Pro and cons, from the speed you will not see any difference. The only pro is that if you share this file, others cannot see the code. But the con is that you have to stick to exactly this Python version. So if you compile something with Python 3.8 and you'd like to run this with Python 2, it will not work. So, or vice versa. So that means pro and con. The easiest thing, if you'd like to share code with others, take the py file and that's it. And then it's interpreted with your Python version and it should work.
Okay, great. Thanks for that one. So we have a third question. So somebody asked, how is it applicable in sport biomechanics? But I would change it a little bit to make it more general. So you showed a few libraries like Numpy and Scipy that are more the Matplotlib-like libraries. But can you tell us about some library for those of us that work in biomechanics in general?
Yeah, sure.
For example,
so I think if you're coming to movement biomechanics, all of us know OpenSim, right? So OpenSim, you can simply do the coding in OpenSim with Python. So that means the scripting language of OpenSim is Python. If you do data visualization, you know ParaView. ParaView, the scripting language of ParaView is Python. Maybe many of us are using Abaqus as a finite element solver. Scripting language of Abaqus is Python. Maybe if you do design, FreeCAD, the scripting language of FreeCAD is Python. And it means I think all really many numerically related commercial or free projects using Python as scripting language, right? And if you would say the pipeline, if you'd like to do not the clicking on an interface, but programming stuff, and as you said, your question with respect to movement biomechanics, OpenSim is Python. So.
Okay, so
of course, many other libraries where the scripting is done in Python.
Yeah, actually, a follow-up question someone wrote is if you see finite element codes like LS9 are going to Python. So I think they are not going to program the solver in Python, but you can already interact with most of them for post processing.
Right, but the reason is because Python was also is known as a gluing language, right? So that means also, for example, ITK, a C++ thing, had SimpleITK. SimpleITK is a simply a Python interface because it's quite easy to interface any kind of C++ code with Python. So that means also I think Altair HyperWorks is having for working or already released that interface in Python. So all these big companies, there is a reason behind it. So I would say it makes definitely sense if you stay in this field of engineering, biomechanics or aerospace engineering or something like that, that you will face, come to the point where you have to use Python. I'm quite sure.
Okay, so final question before we leave. Is there an interface to work with 3D STL files in Python?
3D STL files.
I use VTK. Maybe that's the answer. So I use VTK, which you have to convert the STL files to BTP files, but you can do many things, right, which is what is behind ParaView actually.
Right. So also what we do actually, what we are doing, if we have some data from own written codes, also we did some stuff with 3D printing. This is also a Mat tool. So as you said, we're reading the STLs, usually with VTK. This is a bit of a problem because VTK has sometimes huge changes, and then that means old code is not that portable. But Python is very well portable. Numpy, Scipy is a really perfect stuff, even for a higher version. But yeah, I would read STLs, but STLs is not a good format. I think that's clear. It's not very efficient. As you said, I would immediately read this into a VTK data structure and then work with this VTK thing, because in VTK you can then also script this VTK, which is the basis of ParaView actually. So you have the level of deepness, what you'd like, and then you can open an OpenGL window, visualize it. I did not show this, but yeah. So I would say STL, the best thing, convert it immediately to another format. VTK-based format. I would suggest for FE actually, if you have an FE, if you'd like to an FE input format for your own solver, something like that, I would recommend the Abaqus format, which is also used in calculus. That means this is quite a good format, and you can have it even Abaqus or calculus. This is the free version. It's a free version, totally independent of Abaqus. And I would also recommend, if you do FE, thinking about Fabio. So I would also go in this direction, because Fabio is really made for biomechanics, and it can be combined with OpenSim, and it's a huge open source project. So I really like this way that you say movement biomechanics, OpenSim, finite element world, move to Fabio. That would be great. Also for us as a community, and visualization. I think if you do standard things, maybe Fabio post, or you're using ParaView, which is a fully open thing where you can do, or DK ParaView, where you can do actually everything.
Great. So before saying goodbye to Dieter, somebody asked where can we find this one. So let me share for you for a second my screen. So if you go to www.youtube.com/ESBiomech, we will post here the video, so if you want to go through it. And actually, now that you mentioned FE Bio, we did an FE Bio webinar in the past, so you can guys can also find everything here. So with that said, I think we have no more questions. We are a little bit over time, so let's thank Dieter again for the practical stuff mostly. And I hope this was useful for most of the audience. So thanks, Dieter. Thanks to everyone, and see you soon in the next webinar. Bye bye.
Bye bye.